Hello dear students, welcome to my channel Biochemics with Ajay MNR. Today I'm going to discuss some question and answers from a topic called acids, bases and salts. In this video we are going to learn question and answers, textual question and answers with a detailed explanation. After watching this, please like it, share it and subscribe it. Without further delay, we will start today's class. Our topic is acids, bases and salts. Here is your first question. When a piece of limestone reacts with dilute HCl, a gas X is produced. See, the first statement is a piece of limestone reacts with dilute hydrochloric acid. Then a gas is produced that is named as X. When gas X is passed through lime water, then a white precipitate Y is formed. This is second chemical reaction. First reaction is between limestone and dilute hydrochloric acid, and second reaction is between a so formed gas and lime water. Then Y is formed. Another third substance is formed. On passing excess of X, that same gas, the white precipitate dissolves, forming a soluble compound Z. So here we have three substances. One is X, Y, and Z. So we have to find out what are they based on the given points in the question. And for that we have to write equations also. Now let's see the answer. Here the questions are what are X, Y, Z, and write equations for the reactions which take place. When limestone reacts with the dilute HCl, what is the reaction? When gas X reacts with lime water to form white precipitate Y. A third one is when excess of gas X dissolves white precipitate Y to form a soluble compound. These are the questions. Now we'll see answer. Now here X is carbon dioxide. See here limestone is given. Limestone is calcium carbonate. When there is a carbonate in a substance, when it reacts with an acid, that gives salt, water and carbon dioxide gas. So X is carbon dioxide and Y is a sodium carbonate again. Here when excess of carbon dioxide passes through lime water, that means calcium hydroxide, it forms calcium chloride, calcium carbonate will be formed. It's a white precipitate. And on passing excess of gas X, that means same carbon dioxide, if you pass excess, then white precipitate dissolves, that calcium carbonate dissolves and forming a soluble compound like a calcium hydrogen carbonate. So X is carbon dioxide, Y is calcium carbonate, CaCO3, and Z is calcium hydrogen carbonate, CaHCO3 taken twice. Equations, if you see equations here, the first one calcium carbonate plus 2 moles of hydrochloric acid, that gives you calcium chloride, carbon dioxide and water. Now calcium hydroxide, this so formed gas reacted with calcium hydroxide to form calcium carbonate and water. Now if you pass excess of calcium carbon dioxide through calcium carbonate, that white precipitate dissolves and forms calcium hydrogen carbonate in aqueous solution. This is the answer for this question. Next question. What is the common name of the compound CaOCl₂? CaOCl₂. Now the answer is the common name of CaOCl₂ is bleaching powder. It's a common name actually. bleaching powder. Then what is the scientific name or IUPAC name of CaCl2 is calcium oxychloride. Next question. Name the substance which on treatment with chlorine yields bleaching powder. When bleaching powder or calcium oxychloride reacts with chlorine, that produces certain substances. Now let's see them. The substance which on treatment with chlorine yields bleaching powder is calcium hydroxide. When calcium hydroxide reacts with chlorine, calcium hydroxide reacts with chlorine, that produces bleaching powder or calcium oxychloride. Now, next question. Name the sodium compound which is used for softening hard water. Softening hard water. Sodium carbonate is the compound which is used for softening hard water. Sodium carbonate is also called washing soda, right? Next question. What will happen if a solution of sodium hydrogen carbonate is heated? Sodium hydrogen carbonate is heated, and give the equation of the reaction involved. Answer. Heating sodium hydrogen carbonate yields sodium carbonate and carbon dioxide gas. So in this reaction, if you heat sodium hydrogen carbonate, it is also called sodium hydrogen carbonate, or it's a baking soda. If you heat this one, it yields sodium carbonate, carbon dioxide gas, and water. Now let's see the balanced equation of this one. When two molecules or 2 moles of sodium bicarbonate or sodium hydrogen carbonate or baking soda is heated, that produces U sodium carbonate or washing soda plus water and carbon dioxide, right? Next question. Write an equation to show the reaction between plaster of Paris and water. Plaster of Paris. We know, children, this is a substance which is used for sealing purpose. So plaster of Paris, we call it as a POP, right? The chemical equation for the reaction of plaster of Paris and water. So when plaster of Paris reacts with water, it becomes right. It becomes very hard, very hard. Clear? That is, plaster of Paris is also used in the manufacturing of statues, some decorative shapes, and different things. And calcium sulfate of H2O. This is also called calcium sulfate hemihydrate. Hemihydrate that reacts with 1.5 moles of water, that produces calcium sulfate 2H2O gypsum. It forms gypsum. When plaster of Paris reacts with water, it forms gypsum, that is calcium sulfate dihydrate. Dihydrate. Yes. Next question. A solution turns red litmus to blue. Its pH is likely to be. So children, I think already we discussed that when we have two different types of litmus papers, blue and red litmus paper. When blue litmus paper turns to red, the given substance is acid. When the red litmus turns to blue, it is base. Its pH is likely to be, that means it's more than 7, more than 7, more than 7 to 14. It can be anywhere. Now you see we have options here. Option A 1, option B 4, option C 5, option D 10. Now the correct option is option 10. 10. So 1, 4, 5, they are acidic pH. Less than 7, that shows acidic range. more than 7, that means 7.1 and onwards, it shows a basic range. The answer is 10 because litmus paper turns blue when the solution reacts with a basic solution, right? And pH is more than 7. Hence 10 is the answer. See this picture in this acidic solution, and blue litmus changed to red, and neutral no change, red litmus no change, and in basic the red litmus changes to blue. Here we used red litmus paper to check all three different types of solutions. In acidic solution no change occurred, and basic neutral solution also no change occurred, whereas in basic solution red litmus turns to blue, right? Next question. A solution reacts with crushed eggshells to give a gas that turns lime water milky. So a solution is that there are here two substances. One is a solution which we don't know, and second one is the crushed eggshells. When this solution reacts with the crushed eggshells, that produces a gas, and that gas turns lime water milky. So here we have hint in this question. The gas which turns lime water milky is of course carbon dioxide, and eggshells are made up of calcium carbonate in it, and it's a basic substance, and when it reacts the solution must be an acid. Let's see that. The solution contains what? What is that solution? Option A is sodium chloride, option B hydrogen chloride, hydrochloric acid, option C lithium chloride, option D potassium chloride. So sodium chloride is a salt, so it will not produce any carbon dioxide gas here. It will not react with, and hydrochloric possibility with hydrochloric acid, right? Option is hydrochloric acid. When hydrochloric acid reacts with crushed eggshells, since eggshells contains calcium carbonate in it, that produces calcium chloride, water, and carbon dioxide. Next question. And eggshells contain calcium carbonate, which on reaction with hydrochloric acid liberates carbon dioxide gas, which turns lime water into milky. This is the equation for that. When calcium chloride carbonate reacts with 2 moles of hydrochloric acid, that gives you calcium chloride plus water and carbon dioxide. This carbon dioxide that turns lime water milky. Next question. 10 ml of a solution of sodium hydroxide is found to be completely neutralized by 8 ml of a given solution of HCl. If we take 20 ml of the same solution of sodium hydroxide, the amount of hydrochloric acid solution required to neutralize it will be. See here the reaction between sodium hydroxide and hydrochloric acid. This reaction is called neutralization reaction. When sodium hydroxide reacts with a hydrochloric acid, that produces sodium chloride and water. So they neutralize each other, hence it is called neutralization reaction. But here a quantity is given, volume is given. Volume of NaOH is 10 ml, and volume of hydrochloric acid is 8 ml. Then next tube, a volume of sodium hydroxide is 20 ml. That means it is doubled. Now automatically volume of hydrochloric acid also should be doubled. It should be 16 ml, right? Now let's see options. Option A 4 ml, option B 8 ml, option C 12 ml, option D 16 ml. Now answer is, since 10 ml of sodium hydroxide requires 8 ml of HCl, then 20 ml of sodium hydroxide requires 8 into 2, 16 ml of hydrochloric acid. Now Hence the answer is option D, 16 ml. Next question. Which one of the following types of medicines is used for treating indigestion? Antibiotic, analgesic, antacid, and antiseptic. So here the option is indigestion is due to the excess production of acid in the stomach. Medicines used to treat indigestion is called antacid. We can take examples of like Gelusil, right? Gelusil, antacid, different eno. These are the different types of antacid. Antacids are nothing but they are a basis, alkalis. So they neutralize acid produced in the stomach excessively, and that gives you a relief. Next question. Write word equations and then balanced equations for the reaction taking place. So we have to write a word equation as well as balanced equation for the given situations. When first one, dilute sulfuric acid reacts with zinc granules. That means the action of acid with a metal. Second, when dilute hydrochloric acid reacts with magnesium ribbon. Third, when dilute sulfuric acid reacts with aluminum powder. Fourth, when dilute hydrochloric acid reacts with iron filings. These are the four reactions that we have. So we have to write a balanced equation for them. Now, when dilute sulfuric acid reacts with zinc granules, this is a word equation here. Dilute sulfuric acid plus zinc, that gives you zinc sulfate and hydrogen gas. Equation is H2SO4 in aqueous, and zinc is a metal that produces zinc sulfate and hydrogen gas. Second, dilute hydrochloric acid reacts with magnesium ribbon. Word equation is dilute hydrochloric acid and magnesium, that gives you magnesium chloride and hydrogen gas. 2HCl plus magnesium, that gives you magnesium chloride and hydrogen gas. When dilute sulfuric acid reacts with aluminum powder, so that gives you aluminum sulfate and hydrogen gas. Here is the equation for you. 3 moles of sulfuric acid that reacts with 2 moles of aluminum, a solid, that gives you aluminum sulfate Al2SO4 taken thrice in aqueous, and 3 moles of hydrogen gas. Fourth one, when dilute hydrochloric acid reacts with iron fillings, that gives you ferrous chloride and hydrogen gas. Here is the equation, balanced equation. 6 moles of hydrochloric acid and 3 moles of iron atoms, that gives you, and 3 moles of FeCl2 ferrous chloride and 3 moles of hydrogen gas. These are the word equations and balanced equation for the given different chemical reactions. Now the next question is, compounds such as alcohols and glucose also contain hydrogen but are not categorized as acids. So generally what we know, acids are substances that produces hydrogen ions in the presence of water. But here alcohol and glucose, both of them have hydrogen atoms in them, but still they are not considered as acids. They are neutral compounds. Why? Describe an activity to prove it. Here is your activity. Insert 2 nails into the wooden or rubber cork and place them in a beaker as shown in the figure. Connect the iron nail to a bulb, a 6-volt battery, and a wire connected to the switch. So first we have to construct a basic circuit here, having 2 iron nails and one a wire connecting wire, one 6-volt battery we need. Then pour some alcohol or glucose so as to dip the nails in glucose or alcohol. Turn the switch on and you see bulb not glowing despite of connection to the switch. Now empty the beaker and add the HCl solution. This time the bulb glows. This proves the acid can conduct electricity, right? Here, glucose and alcohol do not produce H plus ions in water, but HCl produces H plus ions in the water. These ions are responsible for conductivity in the circuit. So acids, they generally have H plus ions in them, right? Acids are good conductors of electricity since they produce H plus ions. But alcohol and glucose do not conduct electricity since they do not produce any kind of ions over there. So this is the picture over here. Here you see structure of a circuit which is given. Two iron nails are inserted in a rubber cock. Those two are connected to a battery by 6 volt by two connecting wires, and one switch is here and which is connected to a bulb. When ions are present in a solution, those ions, they act as a conductors of electricity, right? Next question. Why does distilled water not conduct electricity whereas rainwater does? So we know that distilled water, which is free of any ions in it, only water H2O molecules are present in it. But rainwater contains a lot of impurity in it, and those impurities are nothing but some ions present in it. So these ions are responsible for electrical conductivity. Now let's see the answer. Distilled water does not contain any ionic compounds in it, no ions present in it. Whereas rainwater has a lot of more compounds, ionic compounds are present in rainwater. Rainwater has dissolved acidic gas such as carbon dioxide from the air, and that forms carbonic acid. So rainwater has dissolved acidic gas, that is carbon dioxide. So when carbon dioxide dissolves in rainwater, that forms carbonic acid. Its formula is H2CO3, carbonic acid. Now this means that it has hydrogen ions and carbonate ions, H2CO3. Therefore, with the presence of acids, rainwater can conduct electricity since it produces H plus ions. Next question. Why do acids not show acidic behavior in the absence of water? So children, listen here. According to definition of Arrhenius theory, acid is a substance that produces H plus ions in water. And these H plus ions are responsible for electrical conductivity. And condition, we know that without water, acids do not produce any H plus ions, right? So they do not show any acidic behavior in the absence of water. Now let's see the answer. The acidic behavior of acids is because of the presence of hydrogen ions or hydronium ions present in it. Hydrogen ions can only be produced in the presence of water. So without water, it's not possible for acid to produce H plus ions, and therefore water is definitely needed if acids are to show their acidic behavior. So without the water, any acid cannot show any acidic property, right? Next question. There are certain solutions A, B, C, D, and E. That means five solutions are given. When tested with a universal indicator, showed pH as 4, 1, 11, 7, and 9 respectively. Which solution is right? It's A's pH is 4, B pH is 1, C is 11, D is in 7, and solution E is 9. So here with the help of pH paper, we can say if anything is less than 7, it considered as an acid. More than 7, that considered as a base. If it is exactly 7, it is a neutral compound. So A, whose pH is 4, this is absolutely an acid. B, also an acid. C, it is more than 7, it must be a base. D, it is 7, it's neutral. And E, it is more than 7 pH, it must be a base. Now let's see which solution is neutral. Of course, solution C is neutral. And which is strongly alkaline, that means strong base. The one whose pH is more, that is strongly alkaline, that is 11. It's a strong base, that is 11 is like B is a strong base. Strongly acidic, that means the solution whose pH is least, that is strongly acidic, that means mm, it's a B1. It's a B1. Strongly alkaline means it's C. Strongly acidic means it's a B whose pH is 1. Next, weakly acidic. Weakly acidic means here 4. 4 is a weakly acidic, and a weakly alkaline is 9. Right? Now let's check with the answers given here. In increasing order of hydrogen ion concentration, pH 11 C, pH 9 E, pH 7 D, pH 4 A, pH 1 B. Increasing order of hydrogen ion concentration. Lower the pH, higher the hydrogen concentration. We know that pH is nothing but anti-logarithm of hydrogen ion concentration. So higher the pH, lower the acidic nature. Higher the pH, higher the basic nature. Lower the acidic nature. Right? pH 11 is strongly alkaline. pH 9 weakly alkaline. pH 7 is neutral, we know that. pH 4 is weakly acidic acid like vinegar and all these things. pH 1 is strongly acidic, it's like a hydrochloric acid which is present in our stomach. Right? Now, next question. Equal lengths of magnesium ribbons are taken in a test tube A and B. Hydrochloric acid is added to test A, while acetic acid is added to test B. So there is a statement we have, there is a reaction we have. There are two solutions are given here. One is hydrochloric acid, second one is acetic acid. These two are acids. One is strong acid, one is weak acid. These two acids are taken in different test tubes like A and B. Hydrochloric acid is in test tube A, whereas acetic acid is taken in test tube B. And equal lengths of magnesium ribbons are taken to test. So they put magnesium ribbon in each of the test tubes, right? This is the situation we have. Now, amount and concentration taken for both the acids are the same. Same acids are taken, same amount are taken. In which test tube will the fizzing occur more vigorously and why? Fizzing sound, that means rapid bubble formation. Of course, in both the test tubes, a fizzing occur actually. Fizzing occur. Here it is given fizzing occur more. That means I think we have to understand in both the test tube fizzing occurs, but out of these two, one test tube fizzing will be more. And why they are asking. Now, answer. Hydrochloric acid is a strong acid, whereas acetic acid is weaker acid. Fizzing occurs because of the production of the hydrogen gas obtained due to the reaction of the acid on the magnesium ribbon. So it forms magnesium chloride and hydrogen gas. Since hydrochloric acid is a very strong acid, there is a lot of liberation of hydrogen gas from test tube A. So hence we can understand that In test tube A, more hydrogen gas is produced. Hence, the fizzing sound in test tube A is more than test tube B, because hydrochloric acid is a strong acid. Its dissociation is 100%, whereas acetic acid is a weak acid. Its dissociation is less than 100%. Therefore, more fizzing takes place in the test tube A. Right? Now, next question is, a fresh milk has a pH of 6. Fresh milk, that means acidic nature, slightly weak acid since lactic acid is present in it. How do you think the pH will change as it turns into curd? Explain your answer. So, if you add lactic acid to milk, that changes to curd. So, curd also contains lactic acid present in it, but milk has lactose sugar in it. Then what happened? Will there be any change from milk to curd? That we have to see. Answer: fresh milk is turned to curd due to the production of lactic acid present in it. Lactic acid reduces the pH of the milk. That means pH falls below 6, right? Acidic nature increases. Now, 18th question. A milkman adds a very small amount of baking soda to fresh milk. Milkman adds a very small amount of baking soda. Why? Baking soda is a basic substance here. They add milk because actually we think they are adulterating actually, but actually there is a technical reason for this. If you leave milk for a long time, they produce lactic acid, then that milk is not fit for consumption. It turns into curd slowly. So to increase its curdling time, generally milkman adds a baking powder, a baking soda, that is a sodium hydrogen carbonate. Why does the pH of the fresh milk from 6 to slightly alkaline? That means he wants to shift the pH of milk from 6 to slightly alkaline, like 7.1, 7.5, or 8. If you shift that one, what happened? It prevents turning of milk into curd. Thereby, he can store milk for longer time. It won't get spoiled. Why does this milk take a long time to set as a curd? Right? Answers. He shifted the pH of the fresh milk from 6 to slightly alkaline to prevent milk from getting sour due to the production of lactic acid. That means this milk baking soda that slows down the production of lactic acid in the milk. It slows down, right? This milk takes a long time to set into curd because the lactic acid produced here first neutralizes the pH, and then pH is reduced to turn the milk into curd, right? Neutralizes the pH after some time. Again, the pH is reduced to turn the milk into curd. Next question. Plaster of Paris should be stored in moisture container. Explain. Dear students, we know that plaster of Paris, which is used um, to construct ceilings and to prepare sculptures or statues and all, and different shapes. But we have to take care of that while storing them. They must not be a moisture, right? We have to store them in moisture-proof containers because plaster of Paris reacts with moisture and it becomes hardened. That's the reason, right? Now let's see the answer. Plaster of Paris should be stored in a moisture-proof container, right? Moisture-proof container, because Moisture can affect the plaster of Paris by slowing down the setting of the plaster of Paris because of the hydration. Right? This will turn plaster useless. Right? Right? It what will do that a moisture can affect the plaster of Paris by slowing down the setting of the plaster. Then it becomes useless. Next one. What is a neutralization reaction? Give two examples. This we know very well. We already have learned in grade 7, right? Now let's see. The reaction of the acid plus base gives a product of salt and water, which is considered a neutralization reaction, right? When acid reacts with a base that produces salt and water, this is called neutralization reaction. Since acid neutralizes base and vice versa, it's a neutralization reaction. Examples: when sodium hydroxide, it's a strong base, reacts with the hydrochloric acid, it's a strong acid that produces a neutral salt, sodium chloride. It is also called common salt and water. And when magnesium hydroxide, it's called milk of magnesium, reacts with the carbonic acid, it forms magnesium carbonate and water. Right? Now, give two important uses of washing soda and baking soda. These two sodas are important for us. Washing soda formula is Na2CO3, sodium carbonate. Baking soda formula is NaHCO3. This is sodium hydrogen carbonate or sodium bicarbonate. Answer: washing soda. It is used as an electrolyte. Baking soda. It can be used to test the garden soil for acidity. If bubbles are developed, then the soil is too acidic. See here, this baking soda reacts with the acid content present in soil. When acid reacts with the base that produces salt and water, since baking soda is a carbonate that produces carbon dioxide, this carbon dioxide is responsible for the formation of bubbles in the soil. Then we can confirm that soil is too acidic in nature. This acidic nature of the soil is not suitable for plants to grow healthy. Second point, washing soda can be used domestically as a water softener for laundry, right? Second, baking soda, it's if used on washing the car, then it will remove dead bug bodies without damaging the color of the or the paint of the on the car. So baking soda can be used. It removes all dead bug bodies without damaging a paint of the car. So these are the differences, two important uses of washing soda and baking soda. So my dear students, I think we have covered all the question and answers given in textbook. If you have any doubt and queries, please comment, and thereby I'll clarify your doubts. Thank you for watching.